Hey everyone, this is Derek, and in this video we're going to look at identifying where a function is increasing, decreasing, or constant from a graph. And so let's go through a few definitions first. So a graph is increasing if a function goes up, basically, as you go left to right. So increasing is exactly what you would think. If this is a graph of your money, the places where you're happy, where it's getting bigger, that's increasing. Decreasing is going to be where the function is going down, left to right. So somewhere like here, constant is exactly what you would think. It's going to be where the graph is flat. So here's the part where people mess it up. When we're talking about increasing, decreasing, constant, we're going to report the x values on which the behavior is happening, not the y values. So we're not saying it's increasing from -6 to 3. We're going to say it's increasing on this interval right here. This is where it's happening, not by how much. So like if this was your money, you would be saying when it was increasing, not by how much it increased. And then the second thing is for the endpoints, they're never included. And the reason is right here, you don't know what happened before that point to know whether or not it was increasing, decreasing, or constant at this point, because you have no before to compare it to. The analogy I use in class is, if you're looking at an endpoint, if you're looking at just an instant, it's like looking down at your speedometer and taking a picture of that and then saying, okay, was I speeding up or slowing down or staying the same speed? From a picture of your speedometer, you have no idea because you don't know what happened before or after to be able to compare it to. Okay, so for this one, we're supposed to just identify the intervals on which d of x is increasing, decreasing, or constant. And we're going to give our answer in interval notation. Okay, so let's do increasing. I'm gonna do that one in blue. And so we're increasing right here, right? But that is from right there to, it looks like 4. So that's gonna be on that interval. And then it also looks like it bottoms out here, but then is getting bigger from there on out. So it's also going to be on this interval. So again, we're not saying it's going from -3 up to 6. We're saying on the interval 2 to 5, it's getting bigger. So over here, I would write that as -7 to -4. Sorry, this pen is not working out to me. And then union 2 to 5. I'm just going to change that to black because it's not really showing up. So that's the rest of the blue one. And then for constant, that's going to be right here, right, where it's flat. So that's happening, it looks like, between -4 and -1. And then for decreasing, that's this other part. Oops. So that's going to be from here to here. So decreasing, that's going to be from -1 to 2. Oops, -1 to 2. And then give the domain and range. Okay, so domain looks like it's going from -7 up through 5. And now this time we do want to include those points because they're there, right? If I say when x is 5, what's y? You'd say 6. That point exists, so I do want to be careful to include them. So I'm using my brackets. And then for range, that's our lowest point to highest point. And so it looks like lowest is going to go as -6, and the highest it goes is 6.